Welcome to Xamarin University. This is Enterprise 302 using the Xamarin Salesforce component, and my name is Chris van Wyk. This course shows how to use the Salesforce component to authenticate a user, perform create, read, update and delete operations, and execute searches using a mobile application. This course does not cover Salesforce components, architecture, the Salesforce website, creating custom objects, applying custom fields, nor creating a connected application. That content is part of Enterprise 301. If you have not taken Enterprise 301 yet, I would really recommend you doing so before continuing with this course. Today, we're going to show you how to create a new project, integrate the Salesforce component into said project, and use the component to let a user log into Salesforce. We'll then follow up with how to use the component to perform CRUD operations against your Salesforce data, and then implement a client-side class to wrap one of your server-side records. For example, let's say we take the account object and then create client code to represent a row from the Salesforce account table. The last part of today's course will cover how to search across multiple tables, and we'll contrast this against a query that lets you search only within a single table. By the end of this course, you'll be able to write an external application that connects to Salesforce and uses the REST API to work with your Salesforce data. In this first part, we'll see how to create a mobile application and incorporate the Salesforce component. Once done, we're going to look at how to enable our user to log into our Salesforce environment. To achieve our first objective, we need to create a new mobile application. And in our example, we're going to create a Xamarin Forms application. This means two things. Once we've created the project and added the Salesforce component, we're going to create a Salesforce client to allow our user to log in, but we'll need to add a bit of architectural thought to our application, just because we need to handle platform dependencies specifically. The Salesforce component requires to present to the user a login screen, and we'll need to abstract this in such a way as to use it inside Xamarin Forms. The Salesforce component drastically simplifies integrating Salesforce into your applications. It provides a convenient wrapper for the Salesforce authentication process, create, read, update, and delete operations, as well as search APIs. The component handles platform dependencies. For example, on Android, a web view is created, and on iOS, a UI web view for authentication. Each view uses the platform-specific UI mechanisms to instantiate the login UI. On Android, an intent is created, and on iOS, a UI view controller is instantiated. Security is also handled per platform. On Android, the key store is used for user caching, and on iOS, the security keychain. The component is available as an in-project download from the Xamarin Component Store. In terms of adding the Salesforce component to our project, we need to keep the following in mind. The Salesforce component cannot be added to shared projects and does not support portable class libraries. This means that we're going to add the Salesforce component to our platform-specific projects. For example, in a Xamarin Forms shared project, you will add the component twice. Once to your Android project, and then the second time around to your iOS project. The Salesforce Client class is the primary class you will use from the Salesforce component. This class builds the platform-specific UI for you that allows the user to log in. It also handles the OAuth flow and can cache authenticated users so that the user does not have to log in each time they use your application. It also wraps the Salesforce REST API. If you've ever tried coding an OAuth flow manually, you may have noticed that it can be rather tedious and potential error-prone. It's not necessarily difficult, but there are a lot of details to get right. For instance, a few common problems are assembling the strings used to request the authorization code or access token and interacting with a browser or web view to retrieve that authorization code. You will therefore appreciate the fact that the Salesforce component manages this for us. Keep in mind though that nothing would prevent you to still interact with the Salesforce API manually. As we saw in Enterprise 301, Salesforce requires you to create a connected application to expose your Salesforce data to external applications. Therefore, before creating a Salesforce client, you will need to log into your Salesforce environment and create a connected app. Once your connected app is ready, Salesforce will generate a consumer key and a consumer secret for you. You need to copy those values into your client code and pass them to the Salesforce client constructor. While creating your connected app, you are also required to specify a callback URL. The value you enter in the Salesforce website has to match the value you pass to the Salesforce client constructor. Note, the Salesforce website uses the OAuth 1 terms, consumer key and consumer secret, instead of the OAuth 2 terms, client key and client secret. The Salesforce client uses the OAuth 2 user agent flow for the initial authentication, and this requires only the client key and callback. It does not use the client secret. However, the client will also automatically try to refresh the access token when the old one expires, and then it will use the OAuth 2 refresh token flow, which requires the client key and client secret. When using the Salesforce client login UI, you are going to need to put some architectural thought into your application. The Salesforce client gives you the correct UI for whichever platform your code is currently running on. However, it does not display the login screen for you. You will need to write some platform-specific code to show the login screen to the user. For Android, you will request an intent from the client display, and for iOS, you will need to request a UI view controller. In our exercise, we'll use a Xamarin Forms application, which will highlight this concept clearly. As mentioned earlier, the Salesforce component handles the OAuth sequence for you. A few of the key steps in the sequence are as follows. It will display the login screen and watch for the redirect URL and then extract the access token. On iOS, the login UI uses a UI web view inside a UI view controller, and on Android, the login UI uses a web view inside an activity. Behind the scenes, the Salesforce component uses the Xamarin Auth component to help manage the OAuth process. The Salesforce client requests an OAuth scope of API refresh token so it can make API calls and use a refresh token to renew the access token when it expires. The Xamarin Auth code then creates a URI using the Salesforce authorization address, the client ID, redirect URL, and response type set to token. This URI then gets loaded into the UI web view or web view on Android, and once loaded will cause the Salesforce instance to display its login page. The component then waits until the web view sees the callback URL and then parses the access token for later usage. When your user authenticates, the Salesforce client will manage the relevant OAuth flow for you. This means you will need to be able to observe events, most importantly the authentication complete event. The authentication complete event is raised when the user successfully logs in or cancels his or her login, for instance, tapping on the Android back button. As a result, you will be able to subscribe to this event, and while you use this event, you're going to observe the authenticator completed event arguments. From here, you're going to use the ESAuthenticated flag, which tells you the result of the user login. Based on this value, you'll be able to implement the rest of your application logic. Once your user authenticates, you will need to be able to manage some of your user's information. Salesforce Client gives you an iSalesforce user object after a user successfully authenticates. A sample iSalesforce user object is shown here on screen. This interface has a few useful properties. The username has a dedicated property, while other values are in the dictionary called properties. This includes the access token, which is sent with the API call, the refresh token, used to get a new access token as needed, and the instance URL, which is the name of the Salesforce server that hosts your organization's data. As you've seen, Salesforce Client is convenient for users. They don't need to log into Salesforce every time they run the application. It automatically stores the user's access token, refresh token, and other required information on the device. You instantiate the class and provide the information in its constructor, and then this information is saved upon successful authentication. Information is also resaved as needed, for example, after a refresh of the access token. When saving information on Android, the user info is saved using a key store of private keys protected by a fixed password in a private region of the internal storage. And on iOS, it will use the keychain. So this means the security keychain and security record API is going to manage and save the record. When loading information on Android, the Salesforce client is going to sort the saved users by username and then loads the alphabetically listed first item. On iOS, no sorting happens, and the user that is first in the list of returned items from the security keychain will be used. Salesforce Client automatically saves or loads users as needed, so you're not likely to need to do this yourself. It does, however, expose an API to give you some control over this process. For example, you could remove the effect of the auto load by setting current user to null, or you could overrule the selection made during the auto load process by calling load users yourself and then looping through the iSalesforce user objects that were saved. You would then select the current user you'd like to load and assign that one to the current user. Your users might appreciate the convenience of not logging in every time they run your application. And it is quite easy to achieve this. All you need to do is present the login UI when the user isn't a saved user. The Salesforce access token does have an expiration time, after which the user will need to re-log in. Updating an expired access token using the refresh token is built into the Salesforce client. The process works as follows. The Salesforce client instance attempts a token refresh if an API call fails with an invalid session ID. If the refresh succeeds, the original API call is retried. However, if the refresh attempt fails, an invalid session exception is thrown. At this point, you will then be able to manage the process gracefully. Keep in mind that the expiration time for an access token can be configured in your Salesforce instance or environment. You would select the administration category, then security controls, and then you'll be able to select session settings. Something to be aware of is that not all exceptions are manageable through the Salesforce client instance. Some authentication problems are displayed directly to the user via an alert. These are errors raised via JavaScript alerts on the web view being displayed to the user. As a result of this, they are not reported to your client code. With this information now covered, we are ready to create our Salesforce client and authenticate a user. And I would like you to follow me now to our Start Here HTML file so we can have a look at what we're going to cover in our first exercise. Let us have a look at our first exercise for today. Implement an external app and authenticate a user. I would like you to follow me and open up exercise number 1. And in this exercise, the goal of this lab is going to be to instantiate a Salesforce client and use it to display the Salesforce login UI. Now to do this, we're going to make use of our starter version for this exercise, which is in our resources folder within the folder name lab start. In this exercise, you will create a Salesforce client object and display the login UI. To let you spend your time on Salesforce related code in a Xamarin Forms UI, most of the code is already provided. However, I will take you through the elements that we have in this class or inside this exercise so you're familiar in terms of how the exercise code is put together. Now the steps that we're going to follow is to create constants for our consumer key, consumer secret, and callback URL. Once done, we'll create a Salesforce client object, and then we'll obtain the login UI from the Salesforce client and pass it to the pre-written platform-specific code for display. At this point, I would like you to follow me to our IDE, where we're going to open up our solution. To do that, we're going to have a look at our shared project for this solution. So let's have a look at My Campaigns. My Campaigns contains 3 files: a campaigns page, an iAdapter CS class, and a My Campaigns application class. So let's confirm this. Campaigns page is going to display a list view within a stack layout, and in here we'll display some information that we'll retrieve from Salesforce. Right, so we close this and we have a look at iAdapter. You'll notice that iAdapter is sort of start alluding to what we're going to do. We're going to show some UI and then we're going to dispose some UI. you'll notice that show UI takes an object as the UI as a parameter. So this means this is an abstraction, and we most likely is going to retrieve the activity from there as well as the UI view controller. So let's have a look at mycampaigns.cs. mycampaigns.cs is our application class. Notice how we have a property for the iAdapter. So we have a platform specific property, which means if we look at the code in the rest of this class, you'll notice a few things. We have 3 fields here: consumer key, consumer secret, and a callback URL. So most likely this information is going to be retrieved from our application, the connected app that we created in Salesforce. Right, so then we have a Salesforce client, and we're most likely going to instantiate this to allow a user to log in based on the platform that he or she is currently running our application in. So if we move down, you'll notice we have an onStart method. So this is one of the lifecycle methods in our application class, which means this will get called as soon as our application gets instantiated. Notice that we have an onComplete that will handle the authenticate complete event as soon as it is loaded, or gets raised rather. Then we're going to load our users. We're going to make sure that the current user is not null. If the current user is null, we're going to then display the login interface from the Salesforce client. If the user is not null, which means we already logged in, then we're going to display the campaigns page. So let's see what happens here with onComplete. So with onComplete, we're going to make sure that our user was able to authenticate, or if he or she decided to back out of our application, then this will also get raised. Which means whatever we've done up to this point, we'll need to make sure that we dispose the UI that's been raised per platform, so the activity or the UI view controller, and then we'll make sure the user has authenticated. If not, we'll do nothing. Otherwise, we will display the campaigns page. Right, so with this information, let us have a look at the actual implementation on each platform. So let's start with Android. If we have a look at our main activity, you'll notice that main activity, apart from the standard configuration settings that we have, so for instance implementing the forms application activity, we're also implementing the iAdapter interface on this main activity. So this means that at some point we're going to assign this main activity to the platform property on our mycampaigns CS class or application class. And if we have a look at this code, you'll see this is actually true. So once instantiated on the onCreate method, which gets called after instantiation of the activity, we're going to set this value and it will then be assigned to platform. Then we'll continue with initialization of our forms application. As part of the implementation of this adapter, notice the implementation for show UI. So show UI, when it gets called, will start the activity based on the intent received. So this is interesting. Let's go back to the mycampaigns class. So the mycampaigns class is going to retrieve from the client the login interface. So notice here we're going to raise this show method from this main activity, which will start the activity. So this will allow us to retrieve that intent that's going to give us our activity for login, and we'll display it. Alright, so that makes pretty much sense. So we'll have an activity, it'll be displayed, the user will log in, we'll then dismiss it, and then continue with our application page, that campaigns page.cs file that we've created. So let's have a look at what happens in iOS. So in iOS, we're expecting the same kind of thing to happen. So let's have a look. In our application delegate, notice how we also implement the iAdapter interface on our application delegate, which inherits from forms application delegate. But something different is happening here. Forms will create the window, or the UI window, which contains our initial view, will be constructed as part of the base finished launching method. So this is a problem. We need to somehow hijack the initial screen being showed. Luckily for us though, we can create multiple UI windows. If you think back to XAM 101, In that class, we mentioned that we can have multiple UI windows, for instance, to display on screen on the device, and if we have an external UI or interface to a device connected, let's say a projector, we could have a second screen or a second window. So we're going to do something similar. What we are going to do is in this show UI, we're going to instantiate another UI window, set it to the UI screen main screen bound, so it'll be the same size as our screen of our device currently running the application. And then we're going to cast the UI that's been passed into the show UI method as a UI view controller. And then we'll make it key invisible. So this means we'll have two UI windows, the one on top of the other. We'll allow the user to log in with this one created, we see here on screen. And then once done, we'll dispose this window and set it to null. So it will then disappear, and the initial forms window will be displayed, and the application will continue execution as previously. So let's make sure this works. Now, before we can test this, we need to go back to our MyCampaigns class, so the application class, and we need to complete the steps in here to make sure that we have a Salesforce client and that we can log in. So let's do the following. We're going to retrieve the consumer key, consumer secret, and callback URL from our Salesforce account. So to do this, we're going to switch to our web browser. I've already logged into the Salesforce instance, so I'm going to switch to that, and I've also already navigated to my configuration of my applications. So once you're logged in, you're going to head over to the build grouping of options, click on create, and then you'll click on apps. Now I've selected one of the already created applications that I have, and I'm going to use this consumer key that's been provided on screen. And I'm going to use this consumer secret that's currently non-revealed. Also, I'll need to make use of the callback URL. So these three items is going to allow me to get my user to log in, and then also to refresh his access token. So let's do this. Right, so we're back in the IDE. The first thing I'm going to add is the consumer key. The next item I'm going to add is my consumer secret. Now I don't want to type out my consumer secret, so what I'm going to do is I'm just going to stub this. So this will be my consumer secret, and then I will need to supply the callback URL. Now the callback URL is pretty important to get right, so I'm going to specify the one that I've retrieved from the website. At this point, I will be able at least to show the login UI, but not necessarily be able to log in. You need to make sure that you copy the complete consumer secret as required. Right, the next step here is to make sure that we instantiate our client. So to do this, we'll add the following code. We'll create a new Salesforce client, and note how we need to specify the client ID, client secret, and redirect URL. So we're going to make use of our consumer key at the top. Then we'll specify the consumer secret. And then lastly, we'll specify the callback URL. Notice the name differences here between OAuth 1 naming and OAuth 2 naming as part of the parameter names for this constructor. At this point, we'll be able to run this application and we should see a login UI. So let's have a look at iOS first.
Right, so at this point, we've been able to display the UI.
Right, so at this point, we've been able to display the UI, And the UI is specific to iOS, so it created a UI view controller with a web view inside it. I'd be able now to add my username and password and tap on the login to Salesforce button. Now, until I specify the correct consumer secret, I will not be able to complete the login process. So when you create this exercise your side, make sure to specify the correct consumer key. The next step is to make sure that we get the correct Android UI for this application. So I'm going to stop the current running iOS version, and then I'm going to run this into Android. The first thing I'll need to do is make my Android project the startup project. And then we'll be able to select the Xamarin Android Player KitKat version that I'm currently running. Right, so here's our Android application starting up. And as you can see, it's loading our authenticate activity, in which case I'll be able to specify my username and password and login. Again, remember to set your consumer secret key to the one that you retrieve from the Salesforce instance. Right, so this is logging into your Salesforce client from a mobile application using the Salesforce Client object. So let's go back to our slides and have a look at our first flash quiz. Let us complete our first flash quiz for today. First question, which OAuth 2 flow does the Salesforce component use? Is it web server, user agent, or username and password? The correct answer is user agent. Salesforce supports many OAuth flows. However, the Salesforce component uses the user agent flow. Second question, the user has to log in again when the user access token expires. Is this true or false? And the answer here is false. When the current access token expires, the Salesforce component will attempt to get a new access token using the refresh token flow. This does not involve any user interaction, so they do not need to re-enter their credentials. In this objective, you saw how Salesforce Client removes much of the tedium of implementing an OAuth flow. It creates the complex strings needed to get the access token. It hosts the Salesforce login web page, watches for the redirect URL, and extracts the access token. It parses the username and tokens into an easy-to-use iSalesforce user object and caches these iSalesforce user objects securely on the device so users do not have to log in every time they use the application. The Salesforce Client class lets you authenticate a user in about 20 lines of code for both iOS and Android. Depending on your choice of approach though, it is true that you would need to add a little bit more code if you wanted to isolate the platform-specific parts. Now that we have an authenticated user, we can start working with our Salesforce data. Here we'll see how to perform all the CRUD operations. That is, how to query your Salesforce data, create a new record, update a record, and delete a record. Salesforce provides an extensive REST API that an external app can use to access relevant Salesforce data. And you are able to make use of this API in your applications. For example, you can implement HTTP client and call the relevant REST API URLs to retrieve or submit data. However, Salesforce Client does all of that for you. The client wraps the Salesforce REST API, so you won't need to manually create REST style strings for your operations nor parse JSON results into objects. The Salesforce REST API gives you comprehensive access to your Salesforce data. For example, you are able to execute CRUD operations on the standard objects and your custom objects, or you could search across multiple objects. You can even access information like chatter data, the organizational chat functionality inside Salesforce. And then you are able to extract meta information about the REST service itself, for instance, available versions, or your API limits in your environmental metadata. The Salesforce component, however, does not wrap the entire Salesforce REST API, but it does give you access to the most commonly used parts. It provides you access to the SObject, which allows you to create, update, and delete Salesforce data, and it allows you to execute queries within a Salesforce object or table, and then execute searches across your Salesforce environment or across multiple objects. I have just mentioned that the Salesforce API provides you access to an SObject. But what is this SObject? An SObject represents a row from a table. Notice how this is a change in the terminology from the norm in Salesforce, where object means table. SObject exposes three properties: ID, options, and resource name. ID is one of the standard fields, so it has a named property. Other fields go into a dictionary named options to keep this class generic. In other words, most other fields are object specific. For example, the account object has a number of employees field. However, that field would not exist in a custom object such as album or song. The resource name is automatically populated during queries. Data requested from the Salesforce REST API is returned as JSON. This means that the string representation of an object or objects needs to be deserialized into C# objects usable in your code. The Salesforce component parses the JSON returned from the Salesforce REST API and then creates an IEnumerable of SObject for you. It builds one SObject for each row returned in your query. On the slide, you can see an example of such an SObject. All CRUD operations are managed by the Salesforce Client class instance. Since the Salesforce Client interacts with the Salesforce API, the Salesforce Client does all the tedious work of creating REST-style strings, sending them to the Salesforce server, and parsing the returned JSON. As a result, we are able to make use of create async to create a record, query async to query records, update async to update records, and delete async to delete records. Each of these methods makes use of SObject either as a parameter or a return result. Note the implementation of both asynchronous as well as synchronous methods are available. However, you should always prefer to use the asynchronous operations. I'm now going to step through each of these methods to show you how to apply them in your code. Before we look at read or write operations, we need to look at the Salesforce Object Query Language, or SOQL. SOQL is the language you use to write select statements for Salesforce. It will be familiar to people used to SQL. However, there are enough differences that you'll probably want to make sure to read the online documentation to understand the differences completely. Salesforce summarizes the differences between SQL and SOQL in the following way. SOQL doesn't support all advanced features of the SQL select command. For example, you can't use SOQL to perform arbitrary join operations, use wildcards in field lists, or use calculated expressions. We are going to form up a SOQL request and then use it as part of our query. So let's see how we can do this. The query async method runs a SOQL query for you and parses the resulting JSON into an IEnumerable of SObject. You are then able to apply the result as needed in your application. Note the usage of the options property. You will see a little bit later how to encapsulate this result in a more developer-friendly way. One thing to keep in mind is that the Salesforce component assumes SOQL queries contains an ID and will throw an exception if ID is not present in the resulting JSON. The create async method creates a new record in one of your Salesforce objects. So it'll create a row in the table. Important to note that here you must set the resource name to the name of the Salesforce object. The names of all standard objects are listed in the Salesforce documentation for reference. You do not need to set the ID for new records. It is assigned automatically by the Salesforce instance and is returned to you as the result of the create async call. Again, note the usage of the options dictionary. If the method succeeds, then an ID for the newly created record is returned. At this point, you'll then be able to reference this record by ID from your Salesforce instance in the future. So far, the operations have been fairly straightforward. However, updating rows requires a bit more work. The SObject preparing update request event gives you a chance to prepare your data before it is sent to Salesforce in an update operation. And this can be important when dealing with the read-only fields. Consider the following sequence. You run the query select ID, phone, last modified date from account. You then get back an SObject that contains the ID in its own property, and then two entries in the options dictionary, one for the read-write phone field and one for the read-only last modified field. You then proceed to modify the phone number for one of the SObjects and send the modified SObject to Salesforce as an update. The problem here is that the update operation will fail because Salesforce Client will send both fields, phone and last modified date. And the server is not able to modify that read-only field, last modified date. So preparing update request gives us a dictionary containing all the values of the options dictionary. And at this point, we can then clean up the read-only fields, i.e. removing them from the dictionary, and then submit the information back to the server. So let's see how we can implement this. The update async method updates an existing record. Note how we handle the preparing update request event. We use it to remove the read-only last modified date key and value. Update async does not return anything as part of the execution. However, it will throw an exception on failure. So for example, you may receive a web exception reporting 404 where the ID has not been found or it's invalid ID. Or you may receive an invalid field exception for attempting to update a read-only field. And then finally, the delete async method deletes an existing record from a Salesforce object. Note how both the ID and resource name is required for the delete to succeed. This method returns a bool result to indicate success or failure. You are now ready to start on your first individual exercise, and that is to query a standard object. So I would like you to follow me back to the start your HTML file so we can have a look at this exercise in detail. Once you have the start your HTML file open, I would like you to scroll down and select exercise 2. Now in exercise 2, we're going to create a query for a standard object. And the goal here is to query one of the standard Salesforce objects and display the results. The UI will be minimal, so you can spend more time on your Salesforce related code. To do this, we're going to continue from our previous exercise, and we'll select the ID, name, and created date from the Salesforce object named campaign. So this is one of our standard Salesforce objects, which means we don't need to go and customize any data from our side. However, you will need to understand what the campaign object looks like. So for that reason, we do have a link to the documentation for the campaign object. You may also want to look at ID and created date in terms of standard system fields. So there are two standard system fields that we'll select. And again, we have a link to the details about standard fields. So if you need to brush up on this info, please follow these links and have a look. Now, the next step is to familiarize ourselves with the campaign data. So to do that, I would like you to log into your Salesforce account and let's have a look at the campaigns tab that is available as part of the sales application that you have. So if you head over to Salesforce and you're logged in, you'll notice the default sales application that is available has got a few tabs at the top. And the third one of those tabs is called Campaigns. If you select Campaigns, you'll be able to select all active campaigns from here. So I'll tap on Go, and that will display some of our information. From here, we can double check to make sure that whatever we retrieve in our mobile application matches the instance info on our environment. So let's go back to our exercise page. The steps are listed here, but I'm going to now switch to the IDE and go through them one by one. You're welcome to follow along or to complete this exercise on your own afterwards. Once back in your IDE, I would like you to open up the My Campaigns project, and then we're going to open up the Campaigns page CS file. Now this is the page that will present our data to the user. Remember, in our first exercise, once logged in, we saw a blank list view. So in this page, we're going to create a method to deal with the query from Salesforce, and then we'll return that information as part of the onAppearing method or lifecycle method for this page. So let's create a getCampaigns SObject async method. So this method is going to be asynchronous. We don't want to block the main UI thread while waiting for data to return. So it means that we'll need to return a task, which is going to be of list type SObject. So that's campaigns SObjects async. The next step is to do the actual query, or the select. Now to do this, we're going to make use of the query async method on our Salesforce client. And we can get hold of the Salesforce client by using the application class. So let's create a variable. We'll call this SObjects. That'll store the information returned, the IEnumerable of SObject, and then we'll await the method. Now remember, we have both query and query async, but we're going to make use of async, so we'll await this method's return. So app client, our property, our Salesforce property, client property, and then we'll use the query async method. Now this method takes our SOSL query, so this will be select, ID, name, and created date. Now we need to also specify from where we're selecting, so this will be from the campaign object. So that'll return our objects, but this object is not exactly in the correct format or type that we need. So what we'll do is we'll make use of a link, and then we'll call toList on objects. The next step is to add this method's execution into this run method that'll be called from onAppearing. So we'll do this. We're going to need to instantiate the items, or rather set the items on our instantiated list view. So our code will look something like this. So we have item source, and we can set this now to an awaited get campaigns method. So let's run this code and see what it looks like once it executes. Our application loads, we'll wait for the data to return, and there's our campaign objects. Notice though that these objects does look a little bit odd. Not really so much useful, but again, we just want to display the data to make sure they actually retrieve information. So let's go back to our slides. In this module, you saw how the Salesforce component lets you write CRUD operations with very little code. The only strings you have to put together are SOQL queries. Otherwise, you work with SObjects, which are much more pleasant than building REST strings and parsing JSON. However, there is a better way to manage SObjects. You can create custom SObjects to make working with your client-side data easier and less error-prone. We are going to take a look at the worst aspects of working directly with SObject, and then encapsulate them in a class that is much easier to use. For example, you will have named properties for your data instead of a dictionary. As you have seen, the Salesforce component works with SObjects. Queries return a collection of them, while create, update, and delete take one as a parameter. You will agree that the SObject is more convenient than working with JSON. However, using SObject directly is still a bit inconvenient and error-prone. To implement a custom SObject derived type will make the client code much less error-prone. The aim here is to encapsulate SObjects in such a way that you don't have to specify field names as strings, or you don't have to set the resource name, or you don't have to subscribe to preparing update request. Also, we would like to limit the JSON value that is set for options, so provide type conversions. So have a numeric value not as a string value, but as an actual numeric type. It turns out that SObject was really designed to be a base class for your custom types. It has many services that make it relatively easy to write a derived class. Typically, you would write one derived class per object, for example, my account, my case, my lead, where the Salesforce object would be account, case, and lead respectively. As I've mentioned, SObject was designed to be useful for derived classes. If you inspect the object class, you will notice the following. It provides a backing store for the property values. It has a resource name property which is virtual, overridable, and your derived class will manage the preparing update request, hiding the implementation from the consumer of this derived class. This means the SObject class provides enough infrastructure that your custom derived class is typically easy to write but still provides a lot of convenience to the rest of your code. There are several steps to coding a custom SObject. Most steps are mechanical and relatively simple. We're going to code a derived class of SObject, then we'll override the resource name, look at providing properties for each field, and then handling the updates. First, you create your SObject derived class. Then you provide the resource name as the name of the Salesforce object by overriding the base class resource name property. Code that uses this class now does not have to set the resource name on every instance like they needed to when working with the SObject directly. The options dictionary is rather awkward to work with, as you may have noticed already. To improve usability, you want to do the following. You're going to code a property for each field that you need to work with on the client. And then since the options dictionary is the SObject base class and it stores JSON values, you are able to write some type conversion code for non-string types you might need. Your goal here is to change the client code from SOptions bracket name bracket to s.name, which is simpler, less error prone, and more type safe. Finally, you need to handle preparing update requests in your class. The client code should never have to deal with this event. Recall that working with SObject directly required the client to subscribe to this event on every instance. In our example, we're going to wire it up in the constructor of the class and then handle updates as needed. Something that you may have already thought about is that the Salesforce client queries do not automatically integrate with your custom SObject derived type. Queries are going to return SObject, not an instance of the SObject derived class that you have, but the base class. SObject provides a method that converts an instance of the SObject base class to an instance of your custom SObject derived type. Your derived class must have a default constructor though, and this is expressed by the new constraint on the generic parameter t. The converter creates an instance of your derived class and then stores a reference to the existing SObject inside the new object. This lets them avoid copying the data from the old object to the new one. The getOption, setOption methods understands this idea of the inner object. If the inner object is non-null, they forward the operation to the inner object. This means all your properties that uses getOption and setOption for storage will still work even if the instance are created using this type converter. Here we have the standard pattern for this type conversion. First, we're going to run a query to get an enumerable of SObject. Then we'll loop through the SObjects and call the type converter to create an instance of your derived type. Or alternatively, you could use link to instantiate the conversion for you. In this next individual exercise, we're going to create a custom SObject. And I would like you to follow me back to the start here HTML file so we can have a look at the contents for this exercise. Once in the start here HTML file, I would like you to scroll down so we can have a look at exercise number 3, create a custom SObject. In this exercise, we're going to get rid of the SObject and in terms of working with it directly, because it's tedious and error prone. And what we would like to do is create a custom derived class to simplify the client code that we'll write. So this exercise again is a continuation of the previous one. Here you will create a derived class of SObject named campaign, then provide a property for each field you will use in your client application. Once done, we'll override the resource name and then handle the preparing update request event. The steps again in this exercise is detailed, so you're welcome to just now sit back and relax and follow me along, or you're able to recreate the exercise afterwards. So let's switch to the IDE and complete this exercise. Once in the IDE, I would like you to open up the My Campaigns project and then add a new CS file. We'll call this file campaign. This campaign class is required to implement the SObject that we have. Make sure that you resolve the SObject, and then we're going to implement two properties. The first property is going to be the name property, and then the created date. So both of those two we are selecting from our Salesforce instance. We'll start with name. Now, to get and set these values, we're going to need to have a look at the options dictionary that we have. So returning this value will be from the options dictionary. And we'll specify the key to name. To set this value, we're going to again use the options dictionary, specifying the name of the value being set, and then actually setting that value. We'll do the same for the created date. However, our created date is read-only, so we're only going to use a getter in this property. So I'm going to delete the setter here. We'll use the getter. And then we'll return the value again from the options dictionary. Right, so once we have these two properties, the next step is to override the resource name. Now remember, the resource name is also going to be a static implementation. So we're going to implement a constant here as part of the getter. So no one's going to be able to set it. So the next step is to create another string, and we'll call this, let's not implement it, let's rather override the resource name. So we'll override the resource name, and as I've mentioned, we're not going to set this property, we'll only return a value. And here we're going to return campaign. Once we've done this, we need to make sure that we also deal with the preparing update request properly. So we have a created date. As soon as we're going to submit this record for updates, the created date cannot be sent as part of the actual query. So we're going to need to implement preparing update request. And then in preparing update request, or this handler, we're going to then remove the created date option. Remember that update request event arguments is going to give us access to our update data. So we're going to use e.updateData and then the remove method to remove the actual created date, key and value from our dictionary. So by calling remove created date, that will remove the key and the value from the dictionary. The last step here is to do the implementation, or the override rather, for toString. Remember, our data is going to be displayed by the list view, which currently only does a toString on each object. So we'll override toString, and we are going to only display the name as well as the created date. So we can remove the resource name from this string format implementation. The next part of the exercise is to update our custom SObject implementation in our campaigns page. So we're going to exchange it with our newly created campaign object. So I'd like you to go ahead and open up the campaigns page. And we're going to implement a third method here, or at least an additional method, which is going to return the custom objects, but instead of objects, or SObjects, it's going to return campaign objects. So we're going to add another method, and this method, instead of returning a list of SObjects, is going to return a list of campaign objects. So we'll return, or we will call this method getCampaign SObjects async, but we'll rather call it getCampaign's custom objects async. Once we have this campaign specified, we're going to make use of the getCampaign's SObjects async method. We still need to get all the SObjects, but then we'll use the converter to convert each SObject into a campaign object. So to do that, we're going to make use of await getCampaign's SObjects async. And then we're going to create our campaigns. So we'll specify a campaigns variable. We'll then use the SObjects that we're returning from the previous line. And then we'll implement a link select query. We'll select each object in the enumerator. And then we'll use the as converter to specify the type to convert it to. So this will then implement or convert it to campaign. And once complete, we'll return the result of our campaigns. But since this is still an enumerable, we'll need to use the toList link extension method to return a list. The last step here is to update our run method. So instead of displaying a list of SObjects, we're now going to display a list of campaign custom SObjects. So let's test this and run our application into our simulator. So we're expecting to see the toString implementation that we have, which is going to be campaign, then we'll specify name, and then a part of that should be the created date. As we can see, that code did run, and we see those campaign items. So let's go back to our slides and continue with the rest of today's course. It is now time for our second flash quiz. Which operations are generally easier when using a custom SObject derived type versus using SObject directly? Is it setting values, preparing an update, setting the resource name, or all of the above? The correct answer here is all of the above. All of those elements A, B, and C is now made easier using the derived type versus using SObject directly. Second question. The SObject as T method is inefficient since it copies the fields. Is this statement true or false? And the answer here is false. There's no copy made. The original object gets referenced inside our derived class. As we saw, writing a custom SObject is generally a mechanical procedure that doesn't require tricky code. The payoff for a small amount of code, though, is quite large. It simplifies your client code and greatly reduces the chances of making common errors. Up to this point, we've only been able to query for items within an object. With search, you'll be able to find records in multiple tables or objects in your Salesforce instance. In this part, we'll use the Salesforce Search Language to search our data, and we'll see how to execute these searches. Query and search are distinctly different in Salesforce. Query with a select statement looks for records inside a single Salesforce object. Therefore, a SOQL query will only search on a single Salesforce object. Sometimes you need to search across a larger area. Then we'll use Salesforce Search. Salesforce Search can look in multiple objects in a single operation and then return matches from multiple objects. So let's look at what is required to complete such a search. The Salesforce Object Search Language, or SOSL, is the language you will use to write text search expressions across multiple Salesforce objects. SOSL lets you search for matching text anywhere in the Salesforce system, and it does filter results by the permissions assigned to your user. You are able to include in your searches both standard objects and custom objects. And keep in mind that since this is a text search, numeric fields cannot be searched. The Salesforce website includes a number of resources on SOSL, including examples of common searches you may use in your applications. However, on the slide, there's one or two things I want to note. First is we can use wildcards in SOSL queries. So we can use and or. We can specify the types of fields to include. So we can say all fields or email fields, and that will be returned from the object that we're searching on. Note that we can omit the returning clause to search all objects, or we can specify specific objects to return. Something that's really important is the ID field must be returned in your SOSL queries. But we'll talk more about that in the slide to come. SOSL expressions generally include a list of the fields to select from matching records. So for example, the clause returning account ID name asks for the results to include the ID and name fields from the accounts table or object. When inspecting the returned JSON string, this query result also includes additional information. Now, it will include the fields you asked for, but it will also include the record type or the object name, so the table name, and a REST style URI to the record, which is part of your result set. This means you'll be able to access each item via ID and resource name, as well as a direct API call to the URI specified as part of this resource. So as with SObject, Salesforce will wrap this information for us into a C# object you can use. The Salesforce component defines a class named search result, and searches return IEnumerable of search result. So each search result contains the object name, the REST style URL of the record, the ID of the record, and this is likely the most important value since you can use a SOQL query from this point forward to find out more details about the matching record. So it's really important that our queries do include an ID. So as I've mentioned, Salesforce runs a search for you and parses the JSON it gets from the Salesforce instance to create search result objects. Now, only type, URL, and ID from the JSON are loaded into the search result object. All other information is unused. And this is rather interesting. It means that we are going to need to make use of SOQL queries once we have the SOSL result to find out more information. A common practice is to write SOSL searches without explicitly listing the fields to be returned. And this will return only the ID, which is all that is really needed for the search result supplied by the Salesforce component. So again, make sure that ID is included in every raw JSON result, or the search result constructor will throw an exception. So if we think about this concept a little bit, you've noticed in previous searches that we could specify specific fields. So we could say account, bracket, ID, bracket, name. This means that ID and name will be included. So if ID is implied by only specifying the object name, make sure that when you specify fields that you explicitly include ID. Again, if ID is not included, this constructor that creates the search result is going to cause an error to be thrown. So an exception will be raised. From a C# coding perspective, SalesforceClient provides us with a search async method. You're going to pass your SOSL search string as a parameter to this method, and it will return an IEnumerable of search result. Keep in mind there is also a synchronous method available, but you probably want to use the async version to make sure that you do not block the main UI thread as you execute your searches. The result of a search is an IEnumerable of search result, as I've mentioned, and this contains the identity of the matching record. This includes type, URL, and ID, but does not contain the matching text nor any other information about the matching records. You can use the information in search result to get more details on the matching records. The type tells you which object the matching record came from, and you can use this in the from clause of a SOQL query. The ID lets you select the matching record, and you can use this again in the where clause of your SOQL query. So as I've mentioned earlier, SOSL on its own will return information about these objects in terms of where and how we can find them, but once we need more information, we'll need to use a SOQL query. Now that we have covered the Salesforce Object Search Language in theory and how it fits into the Salesforce client, I would like you to follow me back to our start here HTML file so we can have a look at our last individual exercise in which we are going to perform such a search. Once back in the start here HTML file, I would like you to browse down and then select our fourth exercise. In this exercise, we're going to execute a find statement and display the results. So for simplicity, we'll display the returned IDs and object names, but we'll not use the IDs in the select statement to get the actual matching data. So the steps that we would like to complete here is to search for the item or term international in the campaign and the lead Salesforce objects. Then we're going to convert the return search result objects to strings. And then finally, once we have a result and strings, we'll display that to our user. So again, you're welcome to follow along or to complete this exercise on your own pace afterwards. So I would like you to follow me now to the IDE so we can complete the exercise. Once back in your IDE, we're going to open up the My Campaigns project. From here, we'll open up the campaigns page. And we'll add a search result async method to this campaign page to execute a SOSL search. So to do this, we're going to create an async method that will return task list of type string, and we'll call it get search result async. Now, important to note here, get search result, we want to return a list of string, but our search query is going to return a result of search result. So let's define the actual search, and then we'll look at how to translate our search result objects. So we'll specify find the term international in the name field, returning from campaign and the lead object in Salesforce. Important to make sure that you spell your objects properly, so campaign and lead. If this is misspelled, you will get a 404 object not found result from the API. Once we've specified the search term, we're going to make use of the Salesforce client available from the global instance of our application. And instead of using the query async method, we're going to use the search async method. So search async, as is, will return a task of type enumerable search result. So what we'll need to do is we'll need to make sure that we are able to translate or convert each search result object into a string. So let's define our results, and we'll make sure to await this call. And then for the time being, we're going to return null. So at this point, we want to translate each search result. And to do that, I'm going to use this method. I'm going to define a toString method that will take a search result as a parameter and then use string format to return the type, URL, and ID of the result. Then we'll make sure to display search result so as to define that we're not displaying an SObject, nor are we displaying a custom campaign object. This means that we can now complete the get search result async method. And to do that, we'll define another parameter or variable called strings. And this will take results, select each item from result, and then perform toString on that item. And then we'll be able to return strings. Keep in mind that we'll need to perform toList to return a list of string instead of an enumerable of string. The next step is to return this get search result async as the item source for our results list view. So results item source is now going to be set to the awaited result of the get search result async method. So let's test the application and make sure that we get the proper items back. So here's a typical error that can happen. 400 bad request. So this means that somewhere in my SOSL search term, I've spelled something wrong. So let's have a look and see if we can find the error. So we say find international the term in name fields. So note the mistake that I've made here. Instead of saying in name fields, I just returned in name. So now we'll find international in name fields, returning campaign and lead. So let's make sure that this is the correct spelling of the SOSL implementation and our query, and let's run the app again. There's the return types. We find one item in campaign and we found one item in lead. SOSL queries are useful to search across multiple tables at once. Note that to display useful results to the user, you will need to write some more code. Now, you could use the IDs in the search result to select a select statement for each result and then retrieve the matching table rows. So once you have your SOSL result, you will need to combine it with a SOQL query to get the full complete view. Also make sure that you create the proper syntax for each of your SOSL searches as well as your SOQL queries. Otherwise, you'll get either a 404 or a 400 page request from the API. Right, so let's move back to our course and have a look at our slide deck. In this last part of today's course, we've now seen how search is powerful because it lets you locate matching text across your Salesforce data in one single step. However, we need to keep the following in mind. Some processing is required post-execution of a SOSL search. The reason for this is we only get back the identity of the matching record. This means that we'll need to incorporate SOQL queries in conjunction with SOSL searches to find the matching data for each returned result. This concludes Enterprise 302 using the Xamarin Salesforce component. If you have any queries around the contents covered today, you are welcome to ask on the Xamarin University forums available from the Xamarin forums online. I would like to say thank you very much for joining me and best of luck with your projects. Until next time, take care and bye-bye.